Welcome to MRL. In this learning session, we'll learn the solutions of end of chapter exercises of use of coordinates chapter of Ganith Manjari 9th standard CBSE textbook. Now the first question is, we have been asked to tell or find the coordinates of the origin of x-axis and y-axis. We all know that the point of intersection of x-axis and y-axis is origin, and the x-coordinate of origin O is 0, and the y-coordinate of origin is also 0, and therefore the coordinates of the origin is 0, 0. X is 0 and y is 0. Remember that. Now we are also given in the second example. Now W is a point in a coordinate plane. W is a point in a coordinate plane with x coordinate as -5. Please understand this. W is a point in a coordinate plane with x coordinate as -5, and the y coordinate is not given to us, and therefore we can take the y coordinate as any value. Now we have to find the coordinates of another point H. We have to find the coordinates of another point H on a line which passes through W and is parallel to y axis. So please understand this. Now let us go by step. The point H is on a line parallel to y axis. So please understand, the point H is on a line parallel to y axis, and also the line which passes through H also passes through W, and therefore the x coordinate of the point H also has to be -5, because the x coordinate of W is also -5. Now if x coordinate is -5, then the y coordinate of H, either it will be 0 if it lies on x axis, and it will be greater than 0 if it is in the second quadrant, and it will be less than 0 if it is in the third quadrant, as I have shown here in the figure. So therefore remember that the coordinates of H are -5 and the positive value of y if it is in the second quadrant, and -5 and y is equal to 0 if it is on x axis, and it is -5 and negative value of y coordinate if it is in the third quadrant. So please remember that. Now coming to the next example, that is the third example. Here in this example we are given four points and their coordinates. We are given the point R and the coordinates are 3, 0, A coordinates are 0, -2, M coordinates are -5, -2, and P -5 and 2. So we have to locate these coordinates in a graph paper, and join them. So I have located the coordinates R, A, M and P on a graph paper on a coordinate plane, and then I have joined RA, AM and MP and PR. Now the questions are asked are which of the two sides are perpendicular. Very clearly AM is perpendicular to PM, therefore I have written here AM and PM are perpendicular to each other. And also the next question asked is, what is the line segment or the line of this quadrilateral parallel to one of the axes? If you observe here, AM is a line which is parallel to x-axis, and that's what I have written here. AM is parallel to x-axis. And the next question asked is, what are the two points which are images of one another? If you look at this point P and point M, M is the image of P and P is the image of M, because they are at equidistant also, -5, 2 and -5, -2, and therefore the mirror images are P and M, and they are mirror images in x-axis. So please remember, in x-axis, okay, P is the image of M, M is the image of P in x-axis, and that is the question number 3, and that they are the answers for solutions for that particular question. Now coming to the question number 4, again we have been asked here that they have given a point or a coordinate point with a point with coordinates there z5 6. z5 6 are the coordinates given to us. Now we have been asked to construct a right angle triangle IZN. So I have constructed the right triangle in the manner it is appearing there. So IGN is the right angle triangle, and the measure of IZ is 5 units. The measure of Zn is 6 units, and by applying the Pythagoras theorem I can find out the distance in or the length in, the measure in, that is 5 square is 25 and 6 square is 36, 25 plus 6 36 is 61, therefore square root of 61. So in is equal to root of 61 units. So therefore that is how we can find out the lengths of the three sides of the right angle triangle with the given coordinates, and the other two coordinates as it is, you know, that is then it is n 0 and I0 minus 6 are the coordinates of the other two vertices of the given right angle triangle. With one vertex we have drawn the right angle triangle. Of course right angle triangle can be drawn in different ways. This is the one of the ways which I have drawn, remember that. Now coming to the next example, the question is, if we did not have negative numbers, then the coordinates would be, what would be the case of the x-axis and the y-axis, or the coordinate method of representing the coordinate plane by René Descartes. Let us understand this. If we did not have negative numbers, then the coordinates would be only positive integers. We would have only the first quadrant. Then the coordinate system with only positive integers wouldn't facilitate us to locate the points in a 2D plane with very easily or smoothly, as we do it with a system what we have now or what we had earlier, and therefore it is good to have a coordinate system with negative integers. Okay, so try to understand and answer this question. Now given we have the sixth question, we are given the three coordinates here, again the 3 points with their coordinates m minus 3 minus 4, a 0 0 and g 6 8. Now what we have to do is we have to find out whether these 3 points are collinear or they lie on the same line. Now to prove that they are collinear or they lie on the same line, the method is very simple. Let us say m minus 3 minus 4, a 0 0, g 6 8 are lying on a line. Now we have to prove that mg, the length mg, is equal to the sum of the lengths ma and ag. So if we prove this, then the three coordinates will lie on the same line or they are collinear. So let us go one by one. So let us find mg first. Now to find mg I will apply distance formula. It is 6 minus of minus 3, that is 9 square, 8 minus of minus 4, that is 12 square. So 9 square is 81, 12 square is 144, that is 225 square root of 25 is 15. Now let us find ma. Ma is 0 minus of minus 3, 3 square, 0 minus of minus 4 is 4 square, 3 square is 9, 4 square is 16, square root of 25, that is 5. Now ag is 6 minus 0 is 6 square, 8 minus 0 is 8 square, so it is 6 square is 36, 8 square is 64, square root of 100 is 10, and we find that mg is equal to ma plus ag. That means mg is 15, ma is 5, ag is 10. When we add 15 is equal to 15, that means LHS is equal to RHS, and therefore the 3 points, that is m minus 3 minus 4, a 0 0, 0 6 8 are lying on the same line, or we can say they are collinear. So please remember that. Now the next example, again we are again given 3 points R, B, C with their coordinates. Again we have to find out whether R, B and C are collinear or not. Again we will have to follow the same procedure. So we have to find RC, RB and BC. So let us go with one by one. Let us find RC first. It is 4 minus of minus 5, that is 9 square. Minus 12 minus of minus is plus 1, therefore it will be 11 square. So 9 square plus 11 square will be 81 plus 121, that is square root of 202, approximately 14.21. Then RB is minus 2 minus of minus 5, that is minus 2 plus 5, that is 3 square. Then minus of minus 5 plus 1 will be 4 square. So 3 square is 9, 4 square is 16, square root of 25 is 5. And BC, that is the BC here, that is 4 minus of minus 2, that is 6 square. Minus 12 plus 5 is 7 square. So 36 plus 49 is equal to root of 85, so approximately 9.22. Now when we add the two values, that is RB and BC, and RC, when we compare, we find there is a slight difference in the decimal values, and therefore we can say the points are not exactly collinear. Had they been collinear, then the value should have been equal, but here we find the values are not equal, so one is greater than the other, and therefore we can only say the points are not exactly collinear. Let us see when we draw the graphs whether they are collinear or not. So let us draw the graphs, both the graphs the graphs of the points MAG and the graphs of the points RBC. Now when I draw the graph, I find MAG, that is M minus 3 minus 4, A 0 0 and G 6 8, all are lying on the same line, they are collinear. Whereas RBC, if you observe here, R and C are on the same line, but B is outside the line. That means they are non-collinear, and that is exactly what we have shown by our calculations. So the graphs also have proved that our calculations are correct. So please remember that. That's what I mentioned here. The points MAG are collinear and RBC are not collinear or exactly collinear. Okay, remember that. Now coming to the next example. Here we have been asked to draw a right angle triangle with the origin as the vertex, and I have drawn it. So here ABC is a right angle triangle. It is an isosceles right angle triangle. AB is equal to AC here, because AB is also 4 units and AC is also 4 units, and therefore here we have a right angle, that is AB is perpendicular to AC, therefore ABC is a right angle triangle. And also we've been asked to draw an isosceles right triangle, triangle rather, not right angle triangle, isosceles triangle with A as the origin, one of the vertex as the origin, and I have drawn it. That is APQ is an isosceles triangle. As you see that the minus 4 is the center of the base, and to the left we have minus 2 and to the right we have 2. That means the 2 units, that means this is the midpoint, and 100% it is an isosceles triangle. We can, okay, that is what you have to. So this is only what is asked in the example, and that is what we have drawn. Please understand this example. Now coming to the next example, that is we are given a table of coordinates, points SMT. S is one point, M is another point, T is another point. So there are 3 points here. Now we have to tell whether M is the midpoint of the line segment ST or not. So we have a line segment joining S and T. Coordinates are given. So ST is the line segment. Now we have to prove that M, the coordinates of M represent the midpoint of ST, and it is very easy. So what we can do is find SM and MT and show that it is equal to ST, and we can apply distance formula and find it. We have to use distance formula to find the distances SMT, M and ST and show the relation is true. So let us go with the first example. Now SM is 0 minus 3, 3 square, 0 minus 0, 0 square, so it is 3 square plus 0 square, that is root of 9, that is 3. MT is 3 minus 0 is 3 square, 0 minus 0, 0 square, 3 square is 9, again root of 9 is 3, and ST is equal to, ST is 3 minus of minus, that is 6 square, plus 0 square, root of 6 square is 6, and we find that 3 plus 3 is equal to 6, that is SM plus MT is equal to ST, and therefore M is definitely the midpoint of S and T. Now coming to the next example, again same procedure, that find SM, MT and ST and show that SM plus MT is equal to SM is equal to MT, SM plus MT is equal to ST. So let us find SM first. SM is 3 minus 2 is 1 square, and 4 minus 3 is 1 square, so it is 1 square is 1 and 1 square is 1, therefore root 2. Then MT is 3 minus MT is here, MT is 4 minus 3, that is 1 square, 5 minus 4 is 1 square, 1 square plus 1 square is 1 plus 1 and root 2 again, and ST is 4 minus 2 is 2 square, 5 minus 3 is 2 square, and it will be root of 2, that is square root of 2, that is 2 root 2, very simple calculation. So we find that root 2 plus root 2 is 2 root 2, that means SM plus MT is equal to ST, therefore M is the midpoint of ST. So that is the first two are 100% M is the midpoint. Now coming to the third one, SM is 0 square plus 5 square and 5, and TM is 0 square plus 15 square, that is 15, ST is equal to 10. Now we find that 15 plus 5 is 20 and this is 10, and therefore they are not equal. SM plus TM is not, MT is not equal to ST, and therefore M is not the midpoint. And here also SM is root of 8 square plus 9 square, that is root of 145. TM is root of 6 square plus 1 square, that is equal to root of 37. ST is equal to root of 296, and we find that the sum of root of 145 plus root of 37 is not equal to root of 296. We can easily find it, and therefore M is not the midpoint of ST. So therefore in the first two cases M was the midpoint, in the last two cases the M is not the midpoint. Now what we have understood here is, if you look at the example here, so here when I take the average of 3 and minus 3, that is minus 3 plus 3 is 0, 0 by 2 is 0, 0 plus 0 divided by 2 is again 0. If you take the second example, 2 plus 4 is 6, 6 divided by 2 is 3, 3 plus 5 is 8, 8 divided by 2 is 4. By taking the average of the x values, we get 3, and taking the average of y values, we get the y coordinate of the midpoint. So that means by taking the, if I have the two coordinate points a x1 y1 and b x2 y2, then we can find the midpoint of the line joining AB, that is mxy, by taking the average of the x values and the y values, that is by adding x1 and x2 divided by 2 and adding y1 and y2 and divided by 2. So the average of x values gives us the x coordinate and the average of the y values give us the y coordinate. So that is the simple method of finding out the coordinates of the midpoint of the line joining ax1 y1 and bx2 y2. So please remember the discussions what we have done in this, the solutions what we have learnt, and try to note down them in a book for your future reference. Further, the remaining examples will be solving them in our second part of this end of the chapters exercises. Okay, thank you.